Hi students, today's topic is acids and bases. We know what are acids and bases. When a solution is given to us, how to identify whether the given solution is an acid or a base. For that, we need some special substances called indicators, which are otherwise called acid-base indicators. When we put a few drops of that particular indicator to the given solution, we can find out whether the given substance is acid or a base. It is due to change in the color. Based on the change in the color, we can able to say whether the solution is acid or a base. Then why do these acids and bases behave differently or uniquely? So this is due to the presence of special ions called hydrogen ions or hydroxide ions. If a solution contains hydrogen ions, then it is said to be an acid. If a solution contains hydroxide ions, then it is said to be a base. We have already learned that if you take an acid or a base and go on pouring or adding water into it, then the solution, the acid or a base, it goes on decreasing. That means the strength of an acid or a base decreases because on the addition of water, the particular ionic concentration decreases. So then how to find out the strength of an acid or a base, or how to judge how strong an acid or a base is. How to measure strength of acid or base? For this we use universal indicator. So what is a universal indicator? An universal indicator is a mixture of several indicators. It shows different colors at different concentration of hydrogen ions in a solution. For this, we need a measuring scale. So this measuring scale is called pH scale. Then what is pH scale? So pH is a measure of hydrogen ion concentration in a solution. pH scale has values ranging from 0 to 14. The pH of a neutral solution is 7. That means if the pH value is 7, then the solution is said to be neutral. If the pH value falls below 7 and it goes on decreasing up to 0, then the acidity of a solution increases as there is the increase in the concentration of hydrogen ions. And if there is increase of the pH value from 7 to 14, there will be increase in the hydroxide ion concentration. Therefore, there will be increase in the basic value, or the solution is said to be basic, or alkalinity of the solution, it goes on increasing. So therefore, if you take an universal indicator is a paper which is having several colors which shows different pH values at different colors. Remember, the things that we use in our day-to-day life are various chemical substances. That means they must have different pH values. Even if we take our body, so our body contains so many fluids such as blood, urine, like that. So they have their own pH value. So like that, see, the things that we use in our daily life, such as the beverages that we drink, the juices that we use, and then the tap water or different types of the liquids that we use, they have different pH. So then let us have a list of pH values, or how to find out the pH values of those chemical substances that we use in our daily life through a simulation game. There is a simulation game for you to list down the pH values of different substances in our daily life. pH is a scale to measure the strength of an acid or a base. A pH scale is having values ranging from 0 to 14. If the pH value is 7, then the given solution is said to be neutral. Here there is a solution in a beaker whose pH value is 7. That means the solution is neutral. On the right hand side there is a scale which shows the hydronium ion concentration and then hydroxide ion concentration. We know that the pH of a solution depends on the concentration of the ions. If the hydroxide ion concentration increases, the pH value increases and the solution becomes basic. In contrast to this, if the hydronium ion concentration increases, the pH value decreases and then the solution is tend to be acidic. Let us see here now, so whether it is true or not. So here we are having the concentration of hydroxide ion concentration scale. Now I am going to raise the hydroxide ion concentration. You see here, now the pH of this particular solution is gradually increasing because there is increase in the hydroxide ion concentration. As we go on increasing the hydroxide ion concentration, there is increase in the pH value. That means the solution becomes more alkaline or more basic. So at the same time you can see the considerable decrease in the concentration of hydronium ions. So now let us start increasing the hydronium ion concentration. As we know, the hydronium ion concentration increases, the acidity of the solution increases. Let us see this also. Now I am increasing hydronium ion concentration. You can see there is fall down in the pH value. Now you can see here the hydronium ion concentration, as it goes on increasing, there is a fall down. Now it is neutral and then now it is starting becoming basic now. Acidic. Now see here, now it is as you move or as you increase the hydronium ion concentration, there is increase in the acidity of the solution. So this shows that the hydroxyl ion concentration or hydronium ion concentration depends the pH value. These liquids that we use in our day-to-day life are having their own pH value. Even our body fluids have their own pH value. So now let us take some of the things or substances that we use in our day-to-day life and then try to understand their pH value and then try to know how they vary when we go on diluting or concentrating them. Here we have water which is neutral here. To know the neutrality of water, so let us take a device here and then I am going to put this device here. Now you can see what is the pH value. The pH value is 7, therefore the solution is neutral. Now so let me remove this particular liquid. I am removing water now. So I am going to take one more, that is dry cleaner. So I have taken dry cleaner now. Now I am putting I want to know the pH of this particular solution. Now I am going to check with this device. See, the pH is 13. It is highly basic or highly alkaline. The dry cleaner is highly alkaline. And one more now I am going to take, that is our blood, which is the important body fluid. Now let us check the pH value of blood. So I am putting the device once again. See, the pH value is 7.40. That means it is slightly alkaline or basic in nature. Blood is slightly basic in nature. That is more than 7. That is 7.40. So now let me take milk. Right? I have taken milk now. Now I am putting the device once again into this one. See here, the pH value is 6.5. The pH value of pure milk is 6.5, that is milk is acidic in nature. Once again, in the list I am taking the orange juice, right? I have taken orange juice here. Now once again I want to check whether the juice is acidic or basic, or I want to check the pH value. Okay, see, the pH value is 3.50. That means it is highly acidic in nature. Orange juice is highly acidic. Similarly, so I am taking now here coffee, right? Once again I want to check the pH value of coffee, right? It is 5, therefore coffee is also acidic. So now let me check what is going to happen to a solution when we are going to dilute. So if you go on diluting a solution, diluting means addition of water. When we add water to any solution, the concentration of the particular solution decreases. There will be variation in the pH. Now see here, milk. As we know, the pH of milk is 6.5, that is acidic. Now I am adding water. You can observe the pH value of milk by addition of water. What change it is going to happen? When we go on adding water, so the pH value of milk is increasing. That means, so there is decrease in the hydronium ions and then increase in the hydroxide ions. As we go on diluting water, that is milk, the pH value of milk is going to increase. That means it becomes more and more alkaline or basic. So like this, when we take different solutions that we use in our day-to-day life, we can find out the pH values and their variation on dilution. So in the laboratory we may not conduct these experiments by this particular simulation activity or a game, so we can understand the pH values of different solutions, by which we can clearly able to grasp the concept of pH and its variation on dilution.